Welcome back. Today we're going to be talking about linear and nonlinear relationships with tables and graphs. Our content objective is students will be able to determine if a table and graph is linear or nonlinear. Language objective is students will be able to explain why a table and graph can be described as linear or nonlinear. Why am I learning this? Well, it's important for graphing linear equations. So for our first example here, it says determine if the following table represents a linear or nonlinear relationship. If it's linear, determine the equation. So just like our previous lesson, what I think would be a good idea to do first is order all of these ordered pairs in order. And just a quick reminder, we do read graphs from left to right, so I want all of the x values to be in order. So here, if I reorder it like so, and forgive my sloppy handwriting, I'm warning you now. I'm going to first start with -2, -5. I notice I'm saying comma because I'm imagining as if they were ordered pairs. And then I'm going to go ahead and do -1, -2. Then I will go to 0, 1. And then I'm going to do 1, 4. Then it'll be 2, 7. And last but not least would be 3, 10. Now, why would I even want to do this? By doing this, I can see right away the overall trend of this line. If you imagine reading it from left to right, I notice the numbers are increasing. So right away, that's usually a good sign. I can kind of get an idea. It could possibly be linear. Now, the only thing that I would have to do is make sure, in order for it to be linear, that it's moving at a constant rate. So how do I do that? Well, you're basically determining the rate of change, which is the same thing as determining slope. So let's go ahead and find the rate of change between each and every ordered pair. From -5 to -2, we are adding 3. From -2 to -1, we are adding 1. So the slope for this particular two ordered pairs would be 3 over 1, which is just 3. Now I'm going to continue this process with the next two set of numbers. From -2 to 1, we are adding 3. From -1 to 0, we are adding 1. So the slope there is going to be 3 over 1, which is still 3. So right now, it looks pretty good. It seems like it's changing at a constant rate of 3y for each 1x. So I'm going to continue to check. From 1 to 4, we are adding 3. From 0 to 1, we are adding 1. Still looks pretty good. The change is 3 over 1. Continuing again, here we are adding 3. Here we are adding 1. So far, so good. Now, last but not least, from 7 to 10, we are adding 3. From 2 to 3, we're adding 1. So my slope is still 3 over 1, which is 3. Guess what? All of these ordered pairs were moving at a constant rate of change. If it's moving at a constant rate of change, that means your line is a straight line. It is linear. So it's definitely not linear. I can go ahead and answer the fact that it is linear. But according to the instructions, because it's linear, they're going to ask me to determine the equation. Guess what? I already know part of it. My equation is supposed to follow the form y equals mx plus b. It doesn't have to, but this is a very easy form to kind of follow, slope-intercept form. So from here, I can start with y equals, I know what m is. M is 3, so I'm going to put y equals 3x. But now I need to figure out what b is. Hopefully you remember b is always where x is 0 because it has to touch the y-intercept. So what's nice is that was already given to us in our table. When x was 0, y was 1. So here, essentially, this is stating that the y-intercept is 0, 1, which would mean b is 1. So here, I know m is 3. I know b, it's 1. So to finish the equation will be y equals 3x plus 1, because that's what b is. Okay? So now, here's the thing. Will you always have this ordered pair in your table? The answer is unfortunately no. So what could you do? Well, what I would think of it is, okay, well, I know it's going to follow this format, y equals 3x plus something, right? Or plus or minus something. If you figure this, if you pick a nice ordered pair like 1, 4, if you assume x to be 1 and y to equal 4, so in this case, y equals 3x, we know we're going to add something there. If we know y is already going to be a 4 and the x is going to be a 1, so far we have 4 equals 3. Now what needs to happen to 3 to make it a 4? Oh, look, you would just have to add 1 and that would work. So that's one way of doing it, and we're going to have a little bit more practice as we go through the lesson. Now that we've determined the equation from the previous one, let me prove to you that it's linear, just in case you don't believe me. So we've graphed equations before by using slope-intercept form. From this equation, since it is in slope-intercept form, I could identify the fact that b is 1. Therefore, I know the y-intercept is at 0, 1, which would be right here. Now from there, I can go ahead and say I know what the slope is. The slope is 3. Okay, and this is how I got my slope. It was from the equation. I'm going to write 3 as a fraction just so I can easily determine the vertical change over horizontal change. The vertical change is 3, which means it's going to go 3 up. And then the horizontal change is 1, so that's going to go 1 to the right. So I'm going to go ahead and practice that. I'm going to go up from the initial value, aka the y-intercepts. I'm going to go 3 up, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. And in fact, I'm going to practice also going the opposite direction, because slope could also be written as a negative 3 over a negative 1, because a negative divided by negative is still positive. So you can think of it as 3 down over 1 to the left. So let me practice that. Starting from the initial value, we're going to go 1, 2, 3 down, 1 to the left, 1, 2, 3 down, 1 to the left, 1, 2, 3 down, 1 to the left, and there you go. Now drawing a line, you're going to hopefully be convinced that this is indeed a straight line. Therefore, it is a linear, what we're going to be soon calling a function. Okay, so hopefully, now that I've convinced you, let's go ahead and practice a couple more problems. Number 2 is the same instructions like number 1. It says determine if the following table represents a linear or nonlinear relationship. If it's linear, determine the equation. So again, for me personally, I do like to put them in order just so I can get an idea of what's happening to the numbers. Are they getting bigger? Are they getting smaller? So to really assess what's happening with the numbers as they're moving across the x-axis. So here I'm going to go ahead and reorder them. So here's the x's, here's the y's, and the way I'm reordering it is I'm looking at all the x values, and that's dictating what goes first, second, third, etc. So negative 6 will come first, so we're going to write negative 6, negative 1. You can make that look like a negative 1. Then we're going to put negative 2, comma, negative 3. Then we're going to go to 0, comma, negative 4. Then we have 2, comma, negative 5. And 4, comma, negative 6. And last but not least, 10, comma, negative 7. So now that I have these ordered pairs, I just want to take a quick look at the numbers. I notice all the numbers are getting smaller. In fact, because of that, if it is linear, I'm going to know right away that this is a linear function that it's going to have a negative slope. But we haven't proved that it's linear yet. We need to prove it by showing that it's changing at a constant rate. And again, we check that by looking at the slope, because rate of change is slope. So let's try that. Going from negative 1 to negative 3, we are essentially subtracting 2. From negative 6 to negative 2, you're adding 4. So the slope is going to be a negative 2 over 4, which does reduce to a negative 1/2. So right now we want to make sure that the rate of change between every two set points have a rate of change of negative 1/2. If they don't, automatically we know it's not nonlinear. So I'm going to continue from negative 3 to negative 4, we subtract 1. From negative 2 to 0, we are adding 2. So the slope here is a negative 1 over 2, which is negative 1/2. So far, so good. It is moving at a constant rate. From -4 to -5, that's -1. From 0 to 2, that is +2. So the rate of change, aka slope, is once again just -0.5. So right now everything's looking good. I'm going to continue to check. From -5 to -6, we are subtracting 1. From 2 to 4, we are adding 2. So the slope is -1/2. Last but not least, deciding factor, from 6 to -7, we are subtracting 1. From 4 to 10, we're adding 6. So here, the slope is going to be -1/6. Now, was this changing at a constant rate? The answer is no. In fact, we couldn't even see it until the very end. So here's what I don't want to see. I don't want you checking your work and going, maybe this far and thinking, you know what? It's linear. Because we don't know for sure. Notice, I actually had to check the very last one to find out that it actually wasn't linear at all, because it wasn't moving at a constant rate for the entire table. So here, it's actually nonlinear, okay? So notice they didn't ask us for any further details if it was nonlinear, but I do want to talk about something. It is nonlinear. Now, if you look very closely, we could technically describe it. It's not asking us to, but we could still do that. I notice it is nonlinear, and in fact, I notice all the values were what? They were decreasing. So I can kind of describe this as a nonlinear function that is decreasing. So again, they didn't ask me, but it's a good thing to kind of note. So it's not something that we just look and we're like, oh, this is how I find slope. We're assessing the actual table and trying to figure out, the pattern between what we call input and the output. So a key thing is to remember this. Don't assume you must check all of the ordered pairs to see if there is a constant rate of change. And it was all because of the very last one. The rate of change was -1/6, unlike the others, which was -0.5. Now that we've proven it from the table by checking the rate of change and showing that it's not moving at a constant rate, let me go ahead and prove it to you graphically by plotting the points and seeing what the graph actually looks like. So the first point is 0, -4, which is here. 4, -6 is here. 2, -5, which is here. -6, -1, which is here. 10, -7, which is here. And then -2, -3. So looking at this, it appears as though all of these are straight. However, the one point that's not is this point right here. So this just proves that it's not a straight line. In fact, this is what your graph would have looked like. So again, we can clearly see it wasn't moving at a constant rate. And you know what? We did see it for a while, which proves it right here. It was moving at a constant rate at between some ordered pairs. But this one right here is where it changed, and this is the 1/6 that we see. In fact, I'll prove it to you. It went down 1 over 1, 2, 3, 4, 5, 6. So the slope between these 2 points was a -1/6 when the slope between all of these ordered pairs was a -1/2. So because this is not a straight line, it's definitely nonlinear because it's not straight. Number 3, same instructions. Why don't you try and pause the video to see if you can do number 3 by yourself. So for number 3, the first thing that I'm going to do is go ahead and list all of these numbers in orders. That way I can kind of see the general trend of the numbers. Are they getting bigger? Are they getting smaller? Or are they changing in between from getting smaller to bigger, bigger to smaller, etc. So first, put them in order, starting with this, which is 0, -3, 1, 0, 2, 3, 3, 12, and last but not least, 4, 9. Hopefully you understand I'm not making them negative. I'm kind of just checking them off. Maybe using a check mark would have been a better idea. but it's too late now, so we're just going to move on. So here I want to assess what's happening to our y values. As we're moving across the x-axis, what's happening to the y values? Well, here I notice it's increasing, it's increasing, it's increasing, and then bam, it actually decreased right here. So technically, do I already know the answer? The answer is yes. I technically at this point know that it's going to be nonlinear because it was increasing and then all of a sudden it decreased. That's not a straight line. But I want you to inevitably show me that you can see that. So I want you to prove it to me by showing the rate of change. And it's going to be very good practice for you. So let's go ahead and do that. From -3 to 0, what's happening? Well, you are adding 3. So we're adding 3 here. We're adding 1 here. So the slope is 3 over 1, which is 3. Now from 0 to 3, we are adding 3 again. From 1 to 2, we are adding 1. So the slope here is 3 over 1, which is 3. Now from here, 3 to 12, you are adding 9. From 2 to 3, you're adding 1. So here, the slope is 9 over 1, which is 9. So I know just looking at the table initially, as we reordered it, we thought everything looked good, until we got to the 9. But in actuality, it actually was right here. The rate of change was a lot higher between these 2 points than any other points. So here I'm going to stop. I've proven to you that it's not moving at a constant rate. Here, between these 2 order pairs, they're moving at 3y per x, but bam, right here, it moved 9y per 1x. So at this point, I've shown you that it's not linear. In fact, it is nonlinear. And let's go ahead and describe what we saw. Before we even did all of our calculations, we were able to assess, hey, the numbers were increasing, they were increasing, and then bam, it decreased. So there we can say it was increasing, then it decreased. So again, they're not asking me to do this. However, I do want you to recognize those patterns because I want you to use your logic and figure out, okay, this is what's happening to our numbers. And just to reiterate, we know that it's a nonlinear relationship because all of our rate of change that we determined between each 2 ordered pairs, they weren't all the same. They weren't equivalent, which means they're not moving at a constant rate of change. Therefore, it's not going to be a straight line. So for number 4, what I'd like you to do is pause the video and try number 4 by yourself. Okay, so first things first, let's go ahead and put this in order. Starting with, let's check them off this time. 3, -3, and then 5, -2, 6, -1, 8, -4, and 11, -6. So let's look and see, do we notice a trend here? Well, first of all, I notice it was getting larger, right? Going from -3, -2, -1, and then it started getting smaller. So right away, I know this is going to be nonlinear. But I don't want you to get too comfortable with saying, hey, I can just right off the top of the bat. No, it's nonlinear. Again, I want you to prove it to me. So let's go ahead and check to see, the rate of change and determine where things changed. So here, from -3 to -1, we added 1. From 3 to 5, we added 2. So the slope was 1/2, and we did expect that because the numbers were getting bigger. Now here, from -2 to -1, you added 1. From 5 to 6, you added 1. And the slope here is actually 1 over 1. Proof right there. I mean, we saw something different. We saw that it was increasing, and then it decreased. But here, it showed that the rate of change wasn't even the same. So we wouldn't have seen that just by looking at the table alone. So it's important that you are checking them. So here I'm going to say it's definitely nonlinear. And I noticed the trend was it was increasing and then all of a sudden it started decreasing. So it was increasing and then decreasing. But did they ask me to do this? No. However, it's going to be a very good skill to have to be able to assess a table and figure out what's happening to the values. Number 5. Okay, so last one. I want you to go ahead and pause the video and try number 5 by yourself. So once again, I'm going to go ahead and put them in order. Starting with -6, -1, 0, -4, 2, -5, 4, -6, and last but not least, 8, -8. So looking at the numbers, I'm noticing all the numbers are just getting smaller as we assess the y values. So here, let's go ahead and check our rate of change. So right now, there is, the possibility that it is linear because it's all moving within the same direction. All the values are going down. So if it's linear, I expect my slope to be negative. So let's check this out. From -1 to -4, you are subtracting 3. From -6 to 0, you are, adding 6. So the slope so far is -3/6, which is a -1/2, which I expect because the numbers are getting smaller. Slope should be negative. From -4 to -5, you are subtracting 1. From 0 to 2, you are adding 2. So the slope is a -1/2. So far, so good. They are moving at a constant rate. From -5 to -6, subtract 1. From 2 to 4, add 2. So the slope between those 2 points is still -1/2. So again, it's moving at a constant rate. From -6 to -8, subtract 2. From 4 to 8, we add 4. So the slope here is -2/4. Oh wait, that can be reduced to a -1/2. Guess what? There is a constant rate of change. Between every 2 points, they were constantly moving at a rate of a -1/2. So, is this linear? The answer is yes. But we got a little bit more work to do. We need to determine that equation. So here, I already know half of the equation. Okay, I know that the slope is m, so I can go ahead and say y equals, instead of m, I'm going to replace that with a -1/2 x. Now I just got to figure out the plus b. And guess what? I already have enough information. Within this table, I was given the y-intercept. The y-intercept is 0, -4. Therefore, I know that b is -4. So all I have to do here is put -4. Now, what else could you have done to figure out what b was? Well, you already know it's going to be y equals -1/2 x. And it's something here, right? We could have picked an ordered pair. Let's go with this. This is our x value, this is our y. So here I would have plugged in a -5 here, equals, and then a 2 for x. So what's a -1/2 times 2? Well, that would have given me 1. 1 plus or minus what will give me a -5? I correct myself. A -1 plus or minus what number will give you -5? Well, we'd have to subtract 4 because -1 minus 4 gives you -5. So here I would have had to put -4. But do you want to be practicing this if it's already given to you here? The answer is no. But if need be, definitely use this if you're not given the y-intercept within the table. So this is our answer, that it's linear, and the equation would be y equals -1/2 x minus 4. So here's the whole bulk of the lesson. It's a linear equation if the graph is a straight line. It's pretty straightforward. Now, it's a nonlinear equation if the equation, if we graph it, it's not a straight line. Hence, non-linear, not straight. So here, just looking at a couple graphs, we can tell right away if it's linear or nonlinear. For example, this one here is linear, it's a straight line. This one here is nonlinear because it's not a straight line. This is linear, this is nonlinear. Pretty straightforward. So if I asked you to pause the video and try the next four on your own, would you be able to identify them correctly? Well, let's see. This one might be tricky for some of you. Some of you may be a little confused, but ask yourself, is this a straight line? The answer is no. So this one's actually nonlinear. Let's try that again. So this one's nonlinear. This one's definitely nonlinear because it's not straight. This one's also nonlinear because it's not straight. And this one definitely is nonlinear because, again, it's not a straight line. So what do we do to graph a nonlinear equation? Well, first, what you're going to want to do is find at least 5 ordered pairs, input and output, that will make a true statement. And you do want to pick input values that are negative and positives because we do want to see the general shape on the left side of our graph. Let me show you real quick. We want to see the general shape on the left-hand side as well as the right. So picking negatives will show you the shape on the left side. Choosing positive x values will give you the general shape on the right side. So you don't want to just choose positive numbers because then you would only see part of your graph, which could be misleading. So real quick, if I go back for a second, if you only chose positive numbers, which would only give you this portion, kind of got blinders on, you're going to assume it's linear. But because you excluded this, you wouldn't have seen, hey, it's not linear at all. It's actually nonlinear. So it's important that we choose both sides by choosing x values that are negative as well as positive. So some that I like to use would be -2, -1, 0, 1, and 2. 0 being obviously the easiest number, 2 that are positives, and 2 that are negatives. And I kept my input values small. I picked the smallest numbers I could have, which was -1 and -2. Once you get those ordered pairs, simply plot them and connect them to see, is it a straight line or is it not a straight line? So for number 6, it asks us to graph y equals x squared. So the very first thing that you're going to want to do is start with a table. I'm not sure if you remember, but when we started graphing linear equations, that's the very first thing we did. We started with a table. So here, I'm going to go ahead and create a very simple t-chart for the table. We're going to pick some values for x to determine our value for y. Some of the easiest values to pick for x, if we're asked to at least use 5 ordered pairs, I start with the smallest ones you can think of, which would be -2, -1, 0, 1, and 2. So these are all the x values. So here, to determine y, I'm simply plugging in the equation. It says here y equals x squared. So I'm going to put y equals, what is x? Well, x is a -2, so I'm going to go ahead and plug in a -2. And I'm supposed to square that number. So here, to figure out y, I'm just going to take -2 squared means -2 instead of -2, which gives me 4. So our first order pair is going to be -2, 4. I'm going to continue this process here using the equation. Again, we're just going to do y equals. We're going to go ahead and plug in our x. Our x value is a -1. And we're supposed to square that. So what is -1 squared? It means -1 times -1, which is 1. So that order pair would be -1, 1. Moving on to 0. So this is the value for x. We're going to go ahead and plug in y equals a 0 in here for x. We're still going to square it. This means 0 times 0. What is 0 times 0? It's still 0. So this one's going to be 0, 0, which means, hey, it goes through the origin. Continuing on, we're going to put y equals, instead of x, we're going to plug in a 1. We're still going to square that. That's going to be 1 times 1, which is 1. So the order pair is 1, 1. And last but not least, we're going to plug in 2 for x. So y equals a 2. We're going to square that. 2 squared means 2 times 2, which is 4. So our order pair is 1, 4. So now I have 5 ordered pairs. I'm simply going to plot them to see the general shape of it all. -2, 4, which is right here. We're going to do -1, 1, which is here. 0, 0, which is here. Hopefully right away you can see it doesn't look like it's going to be straight. Continuing on, we have 1, 1, which is right here, and 1, 4, which is right there. So this is proof that it's definitely not a straight line. In fact, this has a special name. This is called a parabola. Okay, but clearly we can see this is definitely non-linear. Okay, so with that, let's try a different problem. What if it looks like this? Y equals x cubed. Well, first we got to start with a table, the old-fashioned way, right? So starting with some x values to figure out what y is. I'm going to pick 5 different outputs, and I do want to keep it pretty simple. We want some negatives, we want some positives, so we're going to stick with the old -2, -1, 0, 1, and 2. So here we're going to use our equation to figure out what y is. Y is a x, which is a -2. We're supposed to cube that. So here, what's -2 cubed? I'm just going to show you real quick. -2 cubed means -2 times -2 times -2. Negative times negative is a positive. Positive times negative is a negative. So this is going to be -8. So the ordered pair is -2, -8. I'm going to repeat this process. So y equals, we're going to plug in our -1 in for x, or cube that number. This means -1 times -1 times -1. That's going to be a +1 times a -1, which is a -1. So our ordered pair is -1, -1. Now for 0, we're going to go ahead and put y equals, plug in that 0. It's still being cubed. This means 0 times 0 times 0, which is obviously 0. So we're going to go ahead and write that order pair is going to be 0, 0. Number 1, when x is 1, continuing to plug it in, we're going to go ahead and replace x with a 1 and cube that number. Here it just means 1 times 1 times 1, which I know is 1. So the order pair would be 1, 1. And then last but not least, when x is 2, so we're going to plug in a 2 here, and it's going to be cubed. This means 2 times 2 times 2. When they're all positive, we know this is 8, so obviously this is going to be 8 as well. This was negative, but since all the numbers are positive, it's going to be positive. So that order pair would be 2, 8. So now I have 5 different order pairs. Simply plot them in. So here we go. We're going to plot -2, -8. We have -1, -1, 0, 0. Again, hopefully you can see right away it doesn't look like it's going to be a straight line. I'm going to U graph 1, 1 and 2, 8. So this is the actual shape that it's going to make. It's going to look something like this. So by the looks of it, you tell me, does it look like it's linear? Hopefully your answer is no. It's definitely a nonlinear function. Okay, so we're almost there. We have one more type of graph to do. Here it says y equals the absolute value of x. So once again, I'm going to start with a table. I want at least 5 ordered pairs for this particular type of problem because I want to see the overall shape. So here, picking values for x, I'm going to stick with the old -2, -1, 0, 1, and 2. I'm going to figure out what the y value is simply by using the equation. So here, y is going to be the absolute value of -2. What's the absolute value of -2? Hopefully you remember this from 7th grade. The absolute value is basically the distance from 0. So how far is -2 from 0? It's just 2. So the ordered pair would be -2, 2. So here we're going to do y equals the absolute value of -1. And again, how far is -1 from 0 on a number line? It's 1 away. So the ordered pair would be -1, 1. How about 0? Well, we're going to have y equals the absolute value of 0. The absolute value of 0, well, how far is 0 from 0? it's simply 0. So the ordered pair would be 0, 0. Repeating it again, here we're going to say, well, y equals the absolute value of 1. How far is 1 from 0 on a number line? It's just 1. So the ordered pair is 1, 1. And last but not least, y equals the absolute value of 2. How far is 2 from 0? It's 2 away, so the ordered pair is 2, 2. So now that I have these ordered pairs, so I'm going to go ahead and plot these points. -2, 2, -1, 1, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Hopefully you see from this point as well, it's definitely not a straight line. In fact, if you were to plot more points, it would give you this V-shaped graph. So hopefully you tell me this is definitely also nonlinear. It's not a straight line. I know half of it looks like it's straight on its own, but we need to look at the graph as a whole. So this is definitely nonlinear. So once again, if you didn't choose negative numbers, so real quick, if you completely ignored it and said, I'm just going to pick positive numbers, you may have only seen this side and made the pre-assumption that it is a straight line. But if you uncover the other side, you'd realize, oh wait, it's definitely not a straight line. It is actually nonlinear. So is it important for you to also pick negative numbers for your input values, aka x? The answer is yes, it's absolutely important. Now what we're looking at here are some examples of graphs that are already graphed for you. What I want you to do is look for a pattern. Do you notice any features that all of these graphs have in common? And what do these equations also have in common? Hopefully you've seen that all of these graphs have this general kind of U shape, right? And not only that, there's something that all the equations have in common as well. They all have a x squared. So that must be a determining factor of what our graph is going to look like. Now, let's take a look at this here. So again, here is some graphs. I want you to go ahead and take a quick look at these different graphs. Do they have something in common between the graphs as well as the equations? Hopefully you've seen that all of these equations have the x cubed, right? And they have this general shape right here. So some of them are going up as we read them and some are going down. That might be possibly because this is positive and this is negative. So kind of tie that into stuff that you already know. So maybe after looking at these types of equations, we can quickly assess, oh yeah, it's going to be linear or it's going to be nonlinear, because you have the general shape in mind of what these types of equations look like. So guess what? That actually concludes the lesson for today. Thank you so much for tuning into this very lengthy lesson. Until next time, bye.